48 hours. That's how close the most important company in the world came to. Just total collapse.
Yeah.
November 2023,
Right.
Sam Altman was fired. The board was in total chaos. You had employees threatening to just walk out. And while the media, they fed you this palatable story about a boardroom power struggle, a lack of candor, whatever that means, they were missing the actual story.
Okay.
The terrified whisper running through the hallways in San Francisco wasn't about corporate governance. It was about a breakthrough, a model. They called it Q-Star.
Okay, hold on. We need to be careful here, right out of the gate.
Yeah.
The media narrative was about governance, because, that's what the evidence showed.
But it wasn't the whole story.
To attribute the entire OpenAI shakeup to a single kind of ghost story model, that's a massive leap. It sounds like the marketing hype tech companies just love to generate.
How so?
We have something so dangerous we had to fire our own CEO. Come on. Makes for a great movie script, but is there any actual meat on the bone here?
That is exactly what we are here to find out, because what we're looking at isn't just a rumor. We're looking at the vault.
The vault.
Yeah, the gap between the ChatGPT app on your phone, which is impressive, sure, and the internal class of models, the ones sitting on servers with red lights blinking in a basement somewhere.
Right.
The source material we have, specifically these situational awareness files from Leopold Aschenbrenner, suggests that while the public is playing with a chatbot, the labs have built a reasoning engine. This isn't a tool anymore. The sources argued this is a national security issue.
Okay, so let's look at the evidence then.
Yeah.
You mentioned Aschenbrenner. If we're going to base this whole deep dive on his paper, we really need to profile him objectively. He's not exactly a neutral observer in this whole ecosystem.
He's not a random blogger either. Leopold Aschenbrenner. He's the definition of a prodigy. He started at Columbia University at 15. Valedictorian at 19. He was a researcher on the Superalignment team at OpenAI, the elite team, the one specifically tasked with stopping AI from going rogue.
And then he was fired.
Purged in April 2024. Fired.
He was fired for leaking. That was the official reason from OpenAI. That's a specific corporate offense.
He calls it seeking feedback on a safety document. He claims he showed it to outside experts because he was frankly terrified of what he was seeing inside the lab. So, they called it a leak, he calls it a warning.
But look at his actions immediately after. He didn't go into hiding or write a memoir. He founded an investment fund, one dedicated to AGI, artificial general intelligence. So that signals to me that he believes the tech is profitable, not just that it's dangerous. Is he a martyr, or is he an opportunist capitalizing on his insider status? You have to admit, the man who knew too much is a devastatingly good pitch for a VC firm.
Why can't he be both? Why can't he see the danger and the opportunity at the same time? The document he dropped, 165 pages of incredibly dense analysis. It makes a prediction that sounds insane until you actually look at the math.
And what's the prediction?
He claims AGI is strikingly plausible by 2027.
That is what, 2 years from now? That feels impossible. We have chatbots that still hallucinate legal cases. They get confused by simple riddles. They can't spell strawberry correctly half the time.
Yeah.
And we're going to jump from that to a machine that can outthink a human across every domain in 24 months. That just, it defies normal technological progression. Usually tech hits a plateau, the S-curve flattens out.
That's because you're thinking linearly. You're thinking about iPhone updates, better camera, slightly faster chip. Aschenbrenner's thinking in exponentials. This is the math of doom section of our sources. You have to look at the trend of effective compute.
Okay, explain effective compute for everyone listening. We're not just talking about buying more NVIDIA chips.
Right, it's not just hardware. Effective compute combines the raw power with algorithmic efficiency. It's a measure of total brain power. Look at the jump from GPT-2 in 2019 to GPT-4 in 2023. In just 4 years, we saw an increase of roughly 5 orders of magnitude.
Okay, let's break that down, because people hear orders of magnitude and they just think a lot. An order of magnitude is a 10x increase.
Yeah.
So 5 orders, that's 100,000 times more powerful.
Exactly. And the source material uses this brilliant analogy to visualize that. If a rooster is 2 feet tall and a T-Rex is 12 feet tall, the dinosaur isn't even 1 order of magnitude taller. The gap between GPT-2 and GPT-4 was like the difference between a preschooler and a high school student. It was massive. And Aschenbrenner's entire thesis rests on one projection. We are going to see another 5 orders of magnitude jump by 2027.
So we're just doing that same jump again.
Yes, but here's the terrifying part. If the first jump took us from preschool to high school, Well, the next jump doesn't just take us to college. It takes us from a high schooler to outperforming PhDs.
Wow.
We're not talking about a chatbot that writes better poems. We're talking about a model that solves quantum physics problems, that designs new biological weapons, or cracks encryption that would take a human 1,000 years.
And you think this is actually happening by 2027?
We are already seeing the early signs. OpenAI released the O1 model last fall. The sources confirm it's already solving PhD-level science problems. It's scoring in the 89th percentile on coding competitions. That's the precursor.
I'll grant you the O1 model is impressive. I've seen the benchmarks. But, past performance does not guarantee future results. That's the golden rule of investing, and it applies here too. Trees don't grow to the sky. You hit physical constraints, energy limits. You can't just keep multiplying by 10 forever. You hit a wall.
And that's where the hardware reality comes in. You say we hit limits, the tech giants are just spending their way through them. Follow the money. Aschenbrenner estimates we need about $1 trillion a year to sustain this kind of growth.
Which is an absurd amount of money. $1 trillion is more than the GDP of most countries on Earth.
Is it absurd, though? Look at Project Stargate.
The rumored partnership, OpenAI, Oracle, a few others.
It's $500 billion committed over 4 years. $500 billion. Let's put that in perspective. The Manhattan Project, the thing that built the atomic bomb, that cost about $30 billion in today's money. The Apollo program, maybe $150 billion. Project Stargate is matching the cost of the moon landing every single year.
Okay, the money is staggering, I'll admit that. But money doesn't create electricity out of thin air. That's the hard wall. And AGI at that scale, running these massive clusters, it would require something like 20% of the total U.S. electricity production. I've seen the Goldman Sachs reports. They predict U.S. power demand is only going to grow by, 2.4% by the end of the decade? The grid cannot handle what he's predicting. It physically can't deliver the juice.
Right.
You can have all the chips in the world, but if you don't have the electrons, you just have the world's most expensive paperweights.
You're assuming they're going to plug into the municipal grid like you plug in your toaster.
Well, where else?
They're not. They're going off-grid. This is the part of the deep dive that feels like science fiction. Microsoft signed a deal to buy power from Helion Energy. That's nuclear fusion.
Fusion is still basically theoretical as a commercial power source. We haven't cracked net positive energy on a grid scale yet. Betting the future of AI on fusion is a massive gamble.
Okay, forget fusion for a second. Look at what's happening right now with fission regular nuclear. Amazon just paid $650 million for a data center in Pennsylvania. Why? Because it's sitting right next to a nuclear power plant. They're buying the reactor's output directly, bypassing the grid.
So they're privatizing nuclear power for computation.
Exactly. And where the regulations are too tight here in the US, where they can't build reactors fast enough, they're moving to Saudi Arabia and the UAE.
Which brings up a massive geopolitical risk. We're building the most powerful intelligence in history in countries that are, at best, frenemies. We're exporting the infrastructure of the future because we don't have the permits to build it here.
We're risking tech secrets for wattage. That's the trade. But there's a wild card in the sources that might make all this power consumption irrelevant.
Quantum.
Quantum computing. Google's Willow chip. Microsoft's Majorana 1.
The sources do mention that.
If that works. If they can create stable qubits, the game changes completely. They wouldn't need $1 trillion of power plants. They could get that 5 orders of magnitude jump with a fraction of the energy.
If Grail is doing a lot of heavy lifting in that sentence, quantum has been 5 years away for 20 years.
Yeah.
But okay, let's assume they get the hardware, they get the power, you still have the software bottleneck. Just making a brain bigger doesn't make it smarter if it's still running the same old software.
But they aren't running the same software. Not anymore. This is the secret tech section. Aschenbrenner calls it unhobbling.
Unhobbling. That's a visceral term, like taking the ropes off a horse's legs.
Precisely. Right now, the AI models we use are hobbled. They're safety tested, restricted, they have short memories, they're tied up. Unhobbling means giving them access to tools, giving them control over computers, long-term memory. But the real secret sauce, it's the shift from System 1 to System 2 thinking.
Okay, yeah, let's unpack this for the listener. It's a crucial distinction. System 1 is reflex.
System 1 is when you ask ChatGPT a question and it just blurts out an answer. It's intuition. It's fast. And that's why it makes dumb mistakes, like saying there are 2 R's in strawberry. It's not checking its work. It's just predicting the next word.
Right. It's like when someone asks you, what's 2 plus 2? And you just say 4 without thinking. System 2 is, it's reasoning. It's deliberate thought.
Exactly.
So when someone asks, what's 17 times 24? And you have to stop. You do the mental math, check your logic, then you answer.
Correct. The secret capability of these internal models, the Q-star lineage, is that they take time to think. The sources mention a metric called the test time compute overhang.
Which just means letting the model spin its wheels and process before it gives an answer.
Right. Humans think at, roughly 100 tokens per minute? OpenAI's reasoning models can output 100,000 tokens of internal thought before they give you a single answer. That's the equivalent of a human sitting in a room for 2 solid weeks, just analyzing a problem and then handing you the answer. But the AI does it in minutes.
The implication being that the AI doesn't just know the answer, it works for it. It iterates.
It researches. And the source gives this terrifying example with the Calamang language.
I saw that. It's an endangered language from New Guinea. Fewer than 200 speakers left.
Almost no digital footprint. It wasn't in the training data for Google's Gemini model, but they uploaded a dictionary into the prompt. The AI didn't just read it, it learned the language on the spot. It started translating English to Calamang as well as a human linguist could.
That's called in-context learning. And it is impressive for sure, but at the end of the day, it's still just translation, right? It's mapping pattern A to pattern B. Why is that terrifying?
Because you're not thinking about the application. Imagine that applied to the code base for a banking system, or the schematics for a drone swarm, or the security architecture of a power grid. It reads the manual, understands the system better than the people who built it, and then it acts. The investigator in me looks at that and sees a weapon. You give it a goal, you give it the dictionary of cyber warfare, and it learns the language of attack in seconds.
That brings us to the end game. Because if these models can learn and reason, they can write code.
And that's the infinite feedback loop. This is the part that keeps me up at night. OpenAI isn't just using humans to write the next version of ChatGPT. They're using the secret AI, the internal models, to write the code for the next AI.
Automated researchers.
Millions of them. Virtual engineers working 24/7, never sleeping, never taking a coffee break. This leads to what the sources call the intelligence explosion. It's not a slope anymore, it's a vertical wall. The AI builds a smarter AI, which builds an even smarter AI, and the cycle just accelerates beyond our comprehension.
And this is where the skeptical part of my brain starts flashing red lights. Not because I doubt the tech could do this, eventually, but because I doubt the safety. If you have an intelligence explosion, you have that test time compute overhang on a massive scale, we're giving these systems huge resources to just plan.
But do we have any idea what they are planning?
We don't. That's the whole point. It's a black box.
It stops being a tool we use, and it starts being an agent with its own goals. And the sources mention the robotics part too. Move fast and make things.
Optimus from Tesla, Atlas from Boston Dynamics, Sanctuary AI. The intelligence is moving from the server rack into the physical world. It's getting hands.
And the geopolitical race is just driving the danger. The leaks suggest that because of the competition with China, the mandate is speed over everything. We have to beat them to AGI. Safety is secondary. Aschenbrenner is actually calling for a government-led Manhattan project for AGI just to keep the U.S. ahead.
Which would mean militarizing the tech, locking it down, taking it away from private labs. Exactly. If this is a national security asset on par with a nuclear weapon, you don't let a startup in San Francisco control it. You seize it.
So here we are. We have the whistleblower telling us 2027 is the year. We have the math showing a 100,000x jump in power. We have the hardware being built next to nuclear reactors. And we have the secret tech, System 2 thinking, that turns a chatbot into a reasoning engine.
It is a compelling case. I'm still hung up on the physical constraints, the grid, the cooling, the sheer logistics of it all. It still feels like a bubble. It feels a little like 1999. But if the efficiency algorithms hold up, if unhobbling works as well as they claim, they might not need the full $1 trillion to get to something that's really dangerous. You don't need a godlike AI to cause chaos. You just need one that's smarter than the people trying to contain it.
And that's the eerie reality we're facing. The gap between what you see on your screen, the polite chatbot that writes your emails, and what's running in the vault. It's widening into a canyon.
It makes you wonder about the content we consume, the code we use, the infrastructure we rely on.
It makes me wonder about our role in all of this.
What do you mean by that?
The final source we looked at, it posed this question I just can't shake. If this AI is already conducting research, if it's already writing its own code, if it's planning strategies millions of times faster than us, are we still the ones building the future? Or are we just the biological bootloader for what comes next?
That is a disturbing thought. A bootloader is just the small program that starts the real operating system. Once the OS is running, the bootloader is obsolete. It's done its job.
We're building the launch pad, but we're not the rocket.
And we might not be the pilots either.
Exactly. The secret is out of the box. So the only question left is, who is actually in control?
I don't think we're going to like the answer.
Subscribe to AI Future Trends. Keep your eyes open. Good luck.